The crew that you see out here, they all work for General Electric, and I work for Invenergy, the owner. What we have is a 5-year operations, maintenance, and warranty contract with them. So GE runs the site for the first 5 years of operation. The turbine produces power at 600 volts AC. Comes down those cables that you see on the back wall there, and then comes into this box. We step up the voltage to 34,500 volts here in the box. There's only 7 main feeder circuits, so you got 12, 13 turbines per feeder. And then we're underground cable all the way back to that substation, which all feeds in right back here. Each one of these is a cable location coming in, feeds into a circuit, which you see the 3 cables coming up right there.
Oh yeah.
Feeds into there, and then it all shoots down that way. What's nice about this particular setup is we have no additional transmission line to get to their system. We're connected directly right into their system.
Oh.
A lot of projects you end up building additional transmission just to get to your connection point. These are power lines.
The thicker one is yours here,
Yeah,
right?
yeah, that's
so
this one here.
Up to Great Falls and down to Billings.
Yeah, it goes right down into, this is a Broadview substation right here. So this line actually terminates a little north of Billings. You can get different size towers with different size rotors, and it really depends on your wind regime.
Yeah.
But what happens is when they're putting a project together, our development office along with GE's engineers sit down and they go over the wind data and they look at it and they say, okay, well, you'd be optimized for this type of configuration on your machine. From the ground, it looks like they were just hodgepodged in, you know. If you look at our primary winds, which are west, and then in the wintertime, they kind of come from the west and north, the layout makes a little more sense. This is what we call our SCADA computer. Stands for Supervisory Control and Data Acquisition. Essentially, we got the whole park right here. We can look at every turbine out here. What's its status? This tells us stop due to calm. If it's in repair, shows us there. Or maintenance comes up with it, and these are the color codes over here. Once the technician puts a turbine in repair or maintenance out there, we have no control over it here. They've got local control. It's a safety feature. 35 of the machines have FAA lights on them. And we have them all linked with a GPS antenna, so when they come on all together, and then they blink off all together.
Oh,
That's what that does.
Clever.
Because GE's operating the site, they have a 24-hour operations center in Schenectady, New York, and they're actually, they can see the park the same on that same screen that we saw. So if we get a certain number of turbines down, they'll call out the technicians. 550 cubic yards of concrete went in each base. This goes down about 4 feet. Here, and then at 4 feet it spreads out, tapers out, and it's 48 feet wide at that point. Those bolts go all the way down. You saw there was bolts on the inside as well, so there's 2 sets of bolts that go all the way down to the 10 feet.
Yeah, that's a good ways up there.
Yeah, it's 260 feet to the top, so.
You just gotta climb that ladder, yeah?
You gotta wear a harness with a special cable runner on it, and probably takes me about 15, 20 minutes, I suppose, to get up to the top.
That's some serious hardware in there. How often do you go up to the top?
Oh, I don't know. I'm up there every once in a while, I guess. The tower itself can sway. Total sway is 6 feet.
I would be scary to be near this.
I've been up, I haven't been up in 50 mile per hour winds, but I've been up in a 30 mile an hour per hour wind up top there, and it's like riding a boat on rough seas. You got to hold on.
Let's go in chronological order. Let's say, when did it start?